Hey, I just realized I misspelled the word research. Happens all the time, by the way. I write things down, not thinking about writing. But anyway, I asked you to do some research on how to solve a fourth degree polynomial. And I did give some historical perspective. There's certainly a formula for linear equations, super simple. A formula for a quadratic equation, that's introduced in the Math 100 level. And you did that by completing the square. The cubic formula is not taught much anymore at most schools. Certainly not at Essex County College. And the fourth degree one, I don't think has ever really been taught at the high school level. Now, granted, I hope you did the research, and I want to go through that now. And I gotta say, I'm promoting something that some of your teachers probably say is a bad thing to be promoting, but I don't agree with them. Right? I think what those teachers say Wikipedia is a bad place to go is because it's open source, and they somehow got some suspicion about open source, and they think that if something is paid for, it's better. I got to be honest with you, though, the Wikipedia is an excellent website for research. All right, excellent. All right, a lot of good stuff down there. Certainly, there's a lot of big community members. There's also people that support it financially. I know when they ask me for money, I give it to them. I don't say I give them a lot of money, but I do give them money. But more importantly, there are tons of people out there um, supporting them through writing really nice articles. The problem with these things, sometimes they're long-winded, all right? And this is a quadratic function, fourth degree polynomial. They outline over here, just to point it out to you, looking at it. And let me just go back over here. And I'm looking at this, an algebra, quadratic function, blah, blah, blah. And they talk about, if you read through it, you get that. Eventually, you start to, it's really the history of it, applications, inflection points, golden ratio, nature of roots. It's exhausting, all right? But I want to point out, if you kind of look at it, over here they have the solution to this one over here, which sort of looks like the one we have, all right? Now, the difference between what we have, and I'll go over that again with you, is I'll pull this on the side for you. I think we could get that form. And by the way, the form that they have over here is, x4. So we would just divide both sides by 7 at that point. What would you get? X4. What would the a be? 2. That's what the a would be. Now this would be 3. That's what the b would be. The c would be 2. And the d would be 4/7. So the only number that really presents a problem over here would be the 4/7. But then they got this thing over here. I can't even read it. I mean, if you were to do something like this, I'm going to do this over here and click on it, I start to notice that this thing, it's just crazy looking, right? I'm going to kind of scroll through that with you. That this formula over here, right? This thing I'm looking at over here, right? It's just incredibly long, complicated. Incredibly long and complicated. I mean, so much so that I'm looking at this thing and I'm thinking to myself do I really want to write that down? And the answer to that is a no. I don't want to write it down. So, I'm going to claim over here, I hope you did the research and realize that I'm not going to go there. All right? I'm not going to go there. But where I'm going to go, where am I going to go? I'm going to go to Sage. And let me do that now for you. And in Sage, I'm going to launch Sage for you. And I'm launching it now. And I'm going to try to get Sage to solve that. And by the way, I want to point out, you may wonder if the people that wrote Sage, are they aware of these formulas? Are their education so good that they're aware of this? Of course they are. Right? That's how they wrote these algorithms. They knew about them. And by the way, it's remarkable that they actually knew about it. But reset, I'm going to say x is a variable. I'm being kind of pedantic here with defining the variable. But the bottom line is, I think it's a good idea to get in the habit. I'm going to say the equation EQ, I'll call it EQ1, is going to be assigned 7 star x to the 4th power plus 14 star x to the 3rd power plus 21 star x to the 2nd power plus 14 star x plus 4 double equal sign 0. I'm going to hit the return. I'm going to retype the equation once, see if what I said it's correct. So 7x4, 14x cubed, 21x squared, 14x plus 4 is equal to 0. And I'm going to ask Sage to solve it. All right, I'm not going to go that big long formula. I'm going to see if Sage can do it. So EQ1, and I want to see if it can solve for X. And I'm expecting to see 4 separate solutions to the problem. And let's see what happens. Well, it's working on it. Well, it puts them down pretty quickly. Now, granted, I want to claim to you, I'm no expert. All right, so I'm wondering how Sage did that. Are they using this formula over here? I have no idea. I don't know how they did it. All right, but the bottom line is Sage was able to do that, and that's what I'm going to say. In like mathematics, it's really good to have some historical understanding of polynomials and how much work has gone into those, and why we stop at squares for the most part. Now, by the way, if you look at a traditional algebra textbook, you'll see them go through the formulas up to the cubic, certainly. What I mean by that high school level algebra book, they'd certainly go up to the cubic historically. They'd also do fourth degree polynomials, but they do all kinds of tricks to depress it into maybe a cubic, all kinds of tricks, all right? So be aware of that there's a history here, and this history is used by people to their advantage when they're coding. So I realize some students are going into the coding department at Escana College and want to be computer scientists or coders. It's important to have some kind of perspective here, research. You live in interesting times. What I mean by that, going to places like, I'm sorry about that, going to places like Wikipedia. Let me just go backwards in my Wikipedia. Give me a second over here, backwards again. So I'm at Wikipedia over here, and we found out a nice long article on quartics. Now, I'm not saying you're interested in that. You may not be interested in that, but that's incidental to me. What's important? You start to realize, maybe you could go back to something you're more familiar with. Like, you might want to go back to quadratics. Quadratic equation. Let's do quadratic formula. And you get this, and certainly that'd be a nice little conversation, a much simpler one, by the way. This is one that's really, at Escana College, is taught at the Math 100 level, and we do it by completing the square. It's pretty simple, pretty straightforward. You might want to say, oh, gee, I wonder if there's a cubic equation, and like cubic equation over here. And again, you may be horribly confused reading it, who knows, but it's a lot longer, there's a history to it. You may be interested in that. You may not be interested in that, but there's an history to it. And again, I want to encourage again that Wikipedia is a great place to be going to do research. All right. They talk about a depressed cubic. They talk about a formula for it. By the way, some of the history of this depressed cubic was, kind of like the introduction, the Western world's introduction to complex numbers. All right. But again, they go through a lot of stuff. And again, it might be, you're looking at this thing and you're saying, gee, I wonder how long this goes on. Well, linear, quadratic, cubic, fourth degree. I guess we'd go fifth degree polynomial. Let me write this down. Fifth degree polynomial. I'm just typing in, doing some research. And let's see, quintic, there it is. See that? Quintic. I'm learning a word. And this is an interesting, also historical thing, right? You may want to take a look at that and say, you know what? I'm getting more and more interested in polynomials. And you start to look at them, all right? And it's tough. There's no doubt about it. It's really, really tough. And so much so that I want to be honest with you, myself included, a lot of times things get so tough, you just stop looking, all right? You just stop looking. That's when the adventure ends, though, when you stop looking. You definitely want to think about finding a path to follow where you don't give up. You keep following, you keep going forward. Even if it gets scary to the unknown, you're willing to proceed forward. Thank you so much for paying attention, and I do appreciate that. I hope you understand what I did originally with the problem by making substitutions, that it became a much simpler problem for me. But again, you may say to yourself, I have a better way of doing it, and I'm always encouraging people to have better ways of doing things, all right? But we really beat this thing to a pulp, so to speak, all right? Thank you so much for paying attention.